So now we've established these two quantities, namely sensitivity and specificity. Let's put them into action and see what happens. We said that we have a sensitivity of 0.7333 and a specificity of 0.9715. So suppose we go out and we find a population of 1 million people. And suppose we are now going to screen these people to see how many have TB when we use this test with this sensitivity and this specificity. There's a third quantity we need, and that is the prevalence. How many people actually have TB? So let's use this test to determine what happens in this population of 1 million people with our imperfect test. And what we find is that 28,565 of these people actually tested positive, and the other 971,435 tested negative. That is a typical result when we apply such a screening. Okay? Now, how did we get there? Well, in order to calculate how we got there, we need one other quantity, and that is the prevalence. How many of these 1 million people actually have TB? Let's suppose, just for argument's sake, that the prevalence is 9.3 per 100,000. So that means 93 per million. So suppose we're going into this population of 93 per million. How well will our test act? Well, 93 per million means there are 93 with TB, and that leaves 999,907 without TB. Now, how is the test going to act on these people? Now remember, the test acts differently on people with the disease and people without the disease. So first let's look at people with the disease. To determine how the test acts on those people, we need to know the sensitivity. And we said that the sensitivity was 0.7333. That means that if we subject these 93 people to this test with a sensitivity of 0.7333, we will find that 0.7333 times 93 is 68. We will find that 68 people will test positive. Unfortunately, that also means that 25 people will test negative. What about the people without TB? For them, remember, we have to use the specificity. So the specificity in this case we said was a very high 97%. So 0.9715. So multiply 999,907 by 0.9715, and that will tell us how many people actually test negative. And in this case the answer is 971,410. It's not bad. We missed out on about 3% of the people. But unfortunately, it's 3% of a huge number. So that means 28,497 will test positive who shouldn't test positive. The false positives is very high. Now, we see the impact of this when we draw the line and say, all right, all of this is above the line. We don't see this. What we see is what happens below the line, where the positives are collected, and we find that there are 28,565 positives, and collect the negatives, and we see that there are the remaining 971,435. So this is what we see. We just see below the line. We see how many tested positive and how many tested negative. And because it's an imperfect test, because we have some false negatives, and because we have some false positives, these numbers down here are a little problematic. Typically, we are interested in finding out how many of these positives are truly positive. And what we have here, remember that was called the positive predictive value, and what we have here is that 68 of the 28,565 are true positives. So the positive predictive value is 0.00238. So that's like 2 per 1,000, a little bit more than 2 per 1,000. So of the 1,000 people testing positive, every 1,000 who test positive, only about 2 are true positives. That's the problem with these imperfect tests. Does that mean we should never do this? Well, it's not quite fair to just look at this as a pure number. What we should do is look at it in context. Because the problem was, of course, that these 68 here are swamped by these 28,000 here. That's the problem. Why do we have these 28,000? Well, the specificity was pretty good, 97%. What happened, though, is that this number here is so much larger than this number here. So the way to view this is we are applying this in a situation where we are trying to detect something that is quite rare. Okay? This is the worst case scenario. This is where we're just going out there and just testing everybody. And there's no rhyme or reason for doing the testing other than we're doing a screening of asymptomatic patients. And the correct perspective to view this in is take a look at prior to the test. What did we have prior to the test? Prior to the test, we had 93 per million. So the probability, so we have this haystack out there, and probability of finding a needle in there is 0.000093. It's 93 per million. After the test, we now have the positive predictive value. After the test, we're talking about 68 per 28,000. So the probability now, amongst those who test positive, we've gone from 93 per million, or 0.4093, to 0.202. So if we look at the ratios, it's 25.6. So it's almost a 26-fold zooming, if you will. We're going to zoom in 26-fold because of the test. That is the better way of looking at what the value of such a test is.